for the same scenario, I have already taken a TCP dump. This is idp start.cap. I have taken the private key using the same steps, and I have collected all the information which is required to decrypt the traffic, which is the IDP server IP address, the port on which the IDP server was listening, and the private key. Now, to see the traffic, let's start this using Wireshark. When you open this file, you can see that there are multiple packets. Different protocols are there. The protocol which is in concern is the SSL. If you type SSL here, you can see. So there are a lot of packets are here. And all these packets are in encrypted format. You can see there is a client hello, Gen cipher spec. Everything is in encrypted format. Now, to decrypt this traffic, what you need to do, you have to go to the edit, preferences, select protocol, and then choose SSL. Here you go to the RSA key list, edit, and you have to make entries similar to this. You have to use a new and make an entry. I have already this entry created, but if you make a new, it will give you this kind of form which you need to fill. So if you see this, how it is configured, okay. So in the IP address, you will give the IP address of the server. This can be the IDP IP address, AGI IP address, eDirectory IP address, depending upon what is the server. This is the port on which server is listening. Protocol, you have to use the SSL. Key file, the same private key. You have to, once you click that, you can browse that file. You have to select that, and then the password which you have used to when you were creating the file. Once you do a OK and apply, now the SSL traffic is decrypted. So how to see this SSL traffic? As I said, it contains, when you are doing a TCP dump and you are not taking TCP dump on a particular port, if you just take a TCP dump, it will capture a lot of packets and there will be different SSL communication going on the system. So to take the for our issue, I have accessed the IDP using browser. So my browser is the client and the IDP server is the server. So in that case, I want to see only traffic between the browser and the IDP server. So for this, I have to set some filter, which is the filter should be like SSL, and then use this and ip.addr, and then give the IP address of the IDP server 6, and give the port number. So port number of server is 8443. Now this port number can be different based on the how your IDP server has been installed. So now if you enter, I have filtered many packets here. Now I have mentioned one thing that when you are using the port number, you have to make sure that if the port is not a standard port, you need to decode the packets, otherwise you will not see any information about that. So meaning of the standard port is like, if you are using a HTTP communication, the standard port is 80. If you are using HTTPS communication, standard port is 443. Now 8443 is used for the HTTPS communication, but it is not a standard port. So see the message related to this port. What you have to do, you have to select, go to the port, select the port of the server and right click. It should be the same port, non-standard. Go to decode as. Here you select the destination, it's going to 8443, and from here you select SSL. Apply. Once you do this, then you can see everything related to that particular port, communication of that protocol with that particular port. Now, so here you can see, now I have filtered a lot of packets here. So these are the packets which are in concern. So let's take packet. What we want to see, we want to see the packet where the browser is posting the username and password to the IDP server. So if you see this image, all the communication between the client and server start with the client hello. Okay. Now out of these packets, you cannot just see the packet and tell that which is the actual packet where this communication of posting the data from the browser to the server has happened. So for that, you have to take the client hello and just sort that. So here you can see there are multiple client hello between 214, 146 and 212.124. So here 212.124 is the IP address of the client. That's the browser. And but here you can see there are multiple client hello. So how to know that which is the packet which actually contains that information where where the browser is posting the username and password to the identity server. So for that, you just start with the client hello and do a follow SSL stream. When you do a follow SSL stream, you can see what kind of request is happened during that communication. So here, if you see, it is making a request to the IDP, and then it's accessing some CSS file. Okay, so the first packet is not in concern. Let's take the second one. Again, follow SSL stream. Again, there is not that packet. You have to again take the third one. SSL stream. Here you go. So here you can see there is a post message here, and if you see here, username admin is passed and the password novel is passed. you have decrypted the packet and you can actually see that what password has been sent. Right. Let's go again back and just I'll close it and again open that TCP now. Okay, so I have closed everything and I'll open this TCP dump again and just take the SSL. Now when you give a filter of SSL, it will give you all the SSL traffic. In this SSL traffic, if you see, client. Okay, so now we will just talk about the how this we will try to relate this SSL traffic with this picture. Okay, so the very first request is the client is doing to the server, which is a client hello. So client hello, here my client is the browser, which is 212.124, and the server is IDP, which is 214.146. Here you can see there is a client hello message sent. Okay, if you go here, secure socket layer, client hello, so what do you see here is, if you click on this random, you can see there is a random string sent. So this random string is nothing but this one. This will be used further in creating the master secret. And then you can see the cipher suits. This cipher suit is basically it's a way to say the server that what different algorithms and different uh, encodings need to be used for the encrypting the packets. So this if you see, there is a list of cipher suits. 17 cipher suits are sent by the client to the server. So here you can see TLS, ECDHE, ESCDHA, like this. There are multiple. Now here at this stage, we actually need to make sure that if client is sending some of the cipher suit which has something with the Diffie-Hellman algorithm, if it is there, then probably the decryption will not happen. So this, if there is something with the ECDHE here, then there is a chances that one of these will be selected by the server. If one of these, like ECDHE, this is for the elliptical curve DHE algorithm, Diffie-Hellman algorithm. If any one of something with the ECDHE is selected, then we cannot decrypt that traffic. So in that case, we need to make sure that if client is sending these kind of cipher suits, in that case, identity server should not select this ECDHE. How you will make it confirm? You should go to the server.xml and in this connector contains all the cipher suite which is supported by this server, and in this you should not have that ECDHE. If it will be there, then, and if IDP select that particular cipher suite, then the decryption is not possible. SSL decryption is not possible. But in this case, when the client hello came, it came with this 17 cipher suite, but server in the next step it has selected something which is TLS RSA with AES 128 SHA. It doesn't have the Diffie-Hellman algorithm selected, so this is okay to be decrypted. Now, okay, so the first was the client hello. What is the response of the client hello? We map with this picture. It's a server hello, and the server hello, what it sends a random string again from the server, which will be used to calculate. Oh, sorry, this is the server hello. You can see this is the random string, and there is a cipher suite selected. Random string selected cipher. Okay. The next thing what is sent is the certificate. So server is sending its certificate. Certificate contains the public key of this server, and you can see this is the certificate. If you go into certificate, you can see all the information about the certificate, including the serial number of the certificate, which is the issuer of the certificate, and everything. All the information about the certificate is here. Now, after this step, the client has a random string of server and the server certificate and selected cipher. What client does, it creates a pre-master secret key, and once the pre-master secret key is generated, it generates a master secret key using the pre-master secret key, random string from the client, this one, and random string from the server. Okay, and send this message using a packet called client key exchange. So you can see very next message, the client key exchange. And in the client key exchange, this is the packet, is the client key exchange. You can see encrypted pre-master key. So this one is encrypted using the public key. This pre-master key is encrypted using the public key of the server. This one is encrypted. As it is encrypted, no attacker can take this, can decrypt this value. Now, when this arrives at the server, what server does, server uses its private key to decrypt that. Once it decrypts, the server will also have the pre-master secret key. And once server has the pre-master secret key, it can compute the master secret key here. So master secret key computation function required the pre-master secret key or from the client, random string from the client, and random string from the server. Okay. So after this step, the client also says that send a message called change cipher spec. This message is nothing but it is just an indication that now onwards this pre-master secret key, now onwards whatever pre-master secret key is sent, the client, the pre-master secret key is sent. Sorry. Okay, so this change cipher spec says that now onwards whatever communication will go, it will be encrypted using the master key which is created using the pre-master secret key. It's just an indication message, it doesn't contain anything. And then it sends a message called finished. So you can see a message called finished. Finish is the very first message which client is used to encrypt using the master secret key. So finish is the very first encrypted message. And after that, now once this messages will be over, now client has the master secret key and the server also has the master secret key. So whatever traffic exchange will happen, it will use the master secret key for the encryption and decryption. So client key exchange step will use the asymmetric key cryptography, and after that, after step 4, everything will use the symmetric key cryptography and the key will be the master secret key. Okay, so you can see master secret key, and then there is another message which is going from the IDP server to browser, and it also says that is the same as the change cipher spec. I have not included this. Oh yeah. So now server is sending a chain cipher. IDP server is sending a chain cipher spec to the client saying that K will be used to encrypt the traffic, and it also sends a finished message. And this is finished. After that, whatever the packets are, you can see continuation data. These are all encrypted packets. So now if I click this continuation data, you can see it says that encrypted data here. So all these data are encrypted after that, whatever communication is happening between the client and server. Now, as we have used the private key here to decrypt the traffic, you can see another section here, which is the decrypted SSL data. If you click this, you can see everything which is decrypted. So this is the encrypted format, and this one is the decrypted format. So you can see there is a request get an IDP, IDFF, SO request ID. All these requests are going. If you want to see for a particular SSL communication, what all communication is happening, you have to go to follow SSL stream, click that, and you can see everything decrypted you will get here. So this is how you can decrypt the SSL traffic. The things you need to understand that the SSL decryption we should use only in the case when logs are not sufficient to give you the reason of the issue, and yeah, uh, other than that, you can use to uh, other than the browser communication between browser and IDP and access gateway, you can also use to decrypt the traffic between the access gateway and communication between access gateway and the IDP. One example is the access gateway is sending a um, artifact request to the IDP, and IDP is sending a session. So that traffic also can be done, can be decrypted. Uh, the SSL traffic for the LDAP communication between the identity server and the configuration store or the user store can also be decrypted using the same way. So mm, the basic thing for the decryption is you need to have the IP address of the server, the port number on which server is listening, the private key of the server, and and the password which you have used to generate the private key, and the Wireshark install on one of the servers to see the packet trace. Uh, this is how you can analyze the packet trace on the NAM system. Thank you.